Hello and welcome to this R tutorial. In this tutorial, we are going to solve our business problem using the k-means algorithm in R. So let's start by setting a working directory. So we go to Session, Set Working Directory, and we click on Choose Directory. Then we pick our folder Machine Learning AZ, Part 3 Clustering, Section K-means Clustering, and we click on Open. Okay, now the first step is to import the mul dataset. So let's introduce a new code section with the comment importing the mul dataset. And we import our dataset by typing dataset, left arrow, read.csv, and in parentheses, mul.csv. Okay, let's select this line and hit Ctrl or Command plus Enter to execute. And our dataset is now imported. Let's click on it to see it. Okay, so let's re-explain what this mul dataset is about and what our mission is. There is a big mall in a specific city that contains informations of its clients, the clients that subscribe to the membership card. When the clients subscribed to the card, they provided their information like their gender, their age, and their annual income. And because they have this card, they use it to buy all sorts of things in the mall, and therefore the mall has the purchase history of each of its client member, and that's how they obtain the last column here, which is the spending score. So as a reminder, the spending score is a score that the mall computed for each of their clients based on several criteria, including, for example, their income, the number of times per week they show up in the mall, and of course the amount of dollars they spent in a year. And based on all this, they computed this metric that takes values between 1 and 100, so that the closer the spending score is to 1 and the less the client spends, and the closer the spending score is to 100, the more the client spends. And eventually, after collecting this dataset, the mall company hired you as a machine learning scientist to segment their clients into different groups based on these two metrics, the annual income and the spending score. And since the mall has no idea of what these client segments might be, or even has no idea about how many segments there would be, this is typically a clustering problem because we don't know the answers. So now let's start our mission and use the k-means algorithm to find out what those clusters of clients might be. So here we just imported the dataset, and now let's create a variable x that will only contain the two columns we are interested in, the annual income and the spending score. So here we write x, left arrow, dataset, and then in square brackets we're going to put the two indexes of our two columns of interest. That is, if we go to dataset, since indexes in R start at 1, the indexes of our two columns annual income and spending score are 4 and 5. So here in the square brackets we put 4, 5, which means that we go from 4 to 5. Okay, let's select this line of code and execute it. Perfect. It created the array X of our two columns, which we can visualize here by clicking on X. Alright, now we have all our data well imported and well prepared, and we are ready to move on to the next step. And that's when things start to get interesting. Indeed, right now we are going to start using k-means. So remember, when we use k-means, we have to specify the number of clusters. But the problem here is that we have no idea of how many clusters of clients we are looking for. So we could fit k-means several times on our dataset with different numbers of clusters to test different outcomes. However, there is a much faster way that allows us to find the optimal number of clusters to use with k-means for our problem. And we are, of course, going to use the elbow method. So let's introduce a new section with the comment using the elbow method to find the optimal number of clusters. And in this code section, we're going to make a for loop to plot our elbow method chart. So since there are random factors in k-means, we can obtain slightly different results by using k-means several times. So in order to all get the same result, we are going to set the same seed. And to do this, we type set.seed, and in parentheses we can pick whatever number we like. Let's pick 6. Then we are going to use a for loop to compute some different within cluster sum of squares for different numbers of clusters. And we are going to place the different within cluster sum of squares in a vector. So let's start by initializing this vector by typing WCSS, left arrow, vector, and empty parenthesis. So that just initialized an empty vector, and now we're going to use the for loop to populate it with the different within cluster sum of squares. So let's write for, and in parenthesis, I in 1 colon 10. So in for loops in R, the lower bound and the upper bound are included. So here that means that I is going to take the values from 1 to 10 included. And then at each iteration, we directly compute the within cluster sum of squares for each number I of clusters by writing sum, and in parenthesis, k-means xi to fit the k-means algorithm to our dataset X with I clusters, And by doing that, we actually created an object of the class kmeans in R. And if we select kmeans here, press F1, and then scroll down to value, we see that this class has an attribute called withins that computes the within cluster sum of squares. So let's of course use it and type kmeans xi and then $sign withins. Alright, now thanks to this loop, the WCSS vector is populated with the 10 different within cluster sum of squares for the 10 numbers of clusters 1 to 10. Perfect, so now all we have to do left is plot the graph. So we type plot, and in parentheses we first input the x values, that means 1 to 10, then the y values WCSS. Okay, then let's select plot and press F1. We can specify a type of plot, P to have only points, L to have only lines, and B for both. And we are going to choose both. So B. Then let's give a title to our plot by typing main equals paste and in parentheses clusters of clients. Then we can give a name to our x label, so let's input xlab equals number of clusters, and we give a name to our y-axis, ylab equals WCSS. Now let's select this code section here, and let's execute it to see if we have an optimal number of clusters. And yes, we do! We can clearly see that the point here is the elbow, and when we project this point on the x-axis, we obtain 5 clusters. So that means that the optimal number of clusters for our problem is 5 clusters. And thanks to this insightful information, we are ready to move on to the next step. Because the next step is actually to fit k-means to the mul dataset with the right number of clusters, 5 clusters. So let's introduce this new step with the comment applying k-means to the mul dataset. Then let's set a seed so that we all obtain the same results. We can pick any number, let's pick 29, and then let's fit k-means to our data x. So we create the object k-means from the class k-means, and then let's select k-means here and press F1. The first argument we have to input is our data x, then the second argument is the number of clusters, and now we know it's 5. And then like in Python we can specify a maximum of iterations. Let's use the same value itermax equals 300, and we can also specify the number of initial random sets, and start equals 10. Alright, now we have everything we need and we are ready to select this code section and execute it to fit the k-means algorithm to our data x. Here we go, and perfect! Now let's move on to the next step, and let's get all the fun. Indeed, this is the fun part because we did our job fitting the k-means algorithm to our data x, and now we look forward to seeing the results. So let's immediately introduce this new section, visualizing the clusters. We are going to plot our clusters using the cluster library. So first thing we do is to import the cluster library, and to do this you can either go to packages and select cluster here, or we can type here library and then parenthesis cluster, which is a better way if you want to execute later the whole script. And now let's plot our clusters. To do this, we will use clustplot. Let's select clustplot here and press F1 to see the parameters to input. So the first parameter is our data x. For the second parameter, we input the vector of clusters, that is, the vector that returns for each observation which cluster it belongs to. And we can take this vector by typing k-means $cluster. Then a parameter that we have to specify is lines. Because when you don't give a value to lines, some distance lines between the clusters will appear on your plot. And we don't really want that. So we're going to choose the value 0 so that no distance lines will appear on our plot. Then let's set the parameter shade to true so that the clusters are shaded with respect to their density. Then same for color, let's set it to true. Then we have the parameter labels, and we're going to pick labels equals 2 so that we have all points and clusters labeled in the plot. Then we don't really want different symbols for the points in different clusters, so we set plot car to false. Then we have this cool parameter span that allows us to plot ellipses around the clusters, and in order to plot the ellipses we will set it to true. And finally, we would like to add a title to our plot, so we write main equals paste clusters of clients. Then we want to give a name to our x-axis, so we add xlab equals annual income. And same for the y-axis, ylab equals spending score. And now, moment of truth, let's find out what our 5 clusters look like. We select this code section here, and let's press Command or Control plus Enter to execute. Voila, our 5 final clusters. So let's look at them one by one. Cluster 1. Clients in cluster 1 have high income and low spending score. So in this cluster, clients earn a high income but don't spend much money. So we could call this cluster of clients careful, for careful clients. Cluster 2. Clients in cluster 2 have average income and average spending score. So let's call this cluster of clients standard. Cluster 3, high income and high spending score. So that is the cluster of clients that would be the main potential target of the mall marketing campaigns, and so it would be very insightful for the mall to understand what kind of products are bought by the clients in this cluster. So eventually we can give to this cluster the following name, target. Cluster 4, low income and low spending score. So as opposed to the careless clients who have low income and spend much, we are going to call them the sensible clients. And eventually cluster 5, low income but high spending score. So clients in this cluster earn a low income but don't care and spend much. So let's call this cluster of clients careless. Alright, we are done with the k-means algorithm in R. Look at our code, it's structured, simple, and it does the job perfectly well. And you can use this code anytime you want for your work. You just have to replace the name of the dataset, change the indexes of the columns of interest, and then you just have to execute this code to find some answers of your business problem. And if you are doing clustering in more than 2 dimensions, then don't execute the last code section to visualize the clusters, because it's only for 2-dimensional clustering. However, later in this course, we will learn a technique that allows us to reduce the dimensions of our dataset. So if you reduce your dataset to 2 dimensions, then you can use this last code section to plot the clusters. And now to finish this tutorial, let's clear everything. So we click on this button here. Let's also go here and press Ctrl L to clear the console. We select the whole code, execute it, and we make sure everything works fine. Thank you for watching this video, and I look forward to seeing you in the next tutorial.